Hello, thank you for joining this session today regarding Riverbed Next Generation Labs Path Selection Lab Setup. First of all, you'll need to connect to nextgen.riverbedlab.com. Once you're signed in, you'll go to the dashboard. From the dashboard, you need to go to Topology Sandbox and click on Create More. Once in this area, click on Create a Topology. First step on my topology is entering topology information. The only required field here is your topology name. For this lab, I'm going to call it Path Selection. Next step is to select how many WAN connections you want for your sites. I'm going to select 2, MPLS and Internet. The branch site is going to be San Francisco. These are the settings for that site: latency, bandwidth, and Internet bandwidth. I'm going to have dual router deployment and a single steelhead with dualing paths. You need to select a host to have at that site to generate connections from. It's going to be a Windows PC. Next, we're going to define the data center configuration. We're going to have it identical to the branch, so dual router deployment with a single steelhead with dualing paths. You need to select a server that we're going to connect to. We're going to select a Windows server and a file server. Fourth step, we review the topology we selected, and you can also select your RIOS version. I believe more are coming in future releases. Finish. Then we're going to launch the topology we just created. And wait for the provisioning of all the virtual images. After the images have been provisioned, you'll be connected to the branch host you selected. So in this instance, it's this N21 PC. You can see it's got 2 IP addresses. The 10.99 is a management IP, and the 10.1.21.110 is the test subnet for this site. So first of all, let's connect to the 2 steelheads, which we've got. We've got N20 steelhead 1, and we've got N30 steelhead 1. To get the IPs for these, so we can get to the management console, go to this PuTTY connection manager, connect to them, and then view the IP addresses. N20 steelhead 1 and N30 steelhead 1 in path. Admin and password to connect to them. Get the primary IPs, put them into a browser. We can connect to the steelhead. Log on to both steelheads using the default credentials. Okay, so we've got connection to the branch host, which we're currently on, and 21-PC. We've got SSH to the two steelheads, and management console to the two steelheads. So now we need connectivity to the server. Let's connect to N31-SVR. We need an address to connect to. Which is the name N31-SVR. Let's remote desktop to that server. N31-SVR. Using administrator, and password is mylab with a capital L, bang. All these credentials can be found on this knowledge base article, solutions home, Riverbed hands-on labs, getting started, and the topology diagram. Let's go to the bottom of this solution. Towards the bottom, we have all account credentials for all the lab appliances. So you can see Windows servers, the administrator, user has password mylab bang. Same for the Cisco routers has password mylab bang. Okay, so connect to the server. Once we're connected to the server, we can see the IPs in the top right-hand corner. Need to make a note of the test subnet test IP, which is here. So 1099 is always the management. So for N31-SVR, the test IP is 10.1.31.120. If we run ipconfig, we can see the subnet is in, /24. That's the IP you need to connect to optimize, not the management IP, not the 10.99. Okay. So while we're on that server, let's create a shared drive that we can connect to. We'll create a folder called shared, and I'm going to share it. Just give permission to everyone. If you connect to this share name though, N31-SVR, it won't be optimized, as N31-SVR resolves to the management IP, not to the test subnet, not to 10.1.31.120. So to connect to this share, you need to put in the IP, not the server name. So we can test that, go back onto the host PC, the branch PC, map a drive to that share, 10.1.31.120, shared. Same credentials. Connected to that share. If we check the steelheads, current connections, we should see this connection going through these steelheads, which we can see here. Okay, so now we're going to configure path selection. The topology is in place, connectivity has been tested, so now we need to configure path selection. And we're going to configure it on the client side, so on the branch steelhead, N20 steelhead 1. So first of all, you need to configure sites and networks, and we need to define the remote site. So I'm going to add some networks. I'm going to call one MPLS. And one internet, as per our topology. I'm going to define our local site first. And the subnet of the local site is going to be the PC we're on. So that's 10.99.21. Nope, that's the pod management. So it's the Ethernet adapter, which is N21 San Francisco. So it's 10.1.21/24. So 10.1.21.0/24. And the peers, we need to define the peers. And the peers are actually the in-path IP addresses which exist at this local site, at the site you're defining. So we'll open another connection to this branch steelhead. And we'll get the in-path details. So remember, when we selected the topology, we chose dual in-paths. So first in-path 00, 10.1.120.21. So we'll put that in. And the second in-path is 10.1.220.21. So we'll select that and put that there as well. So we define this site as having this /24 subnet and these two in-paths. Then uplinks, we know it's got in-path 00 and in-path 01. I'm going to change the names to correspond with our topology. I'm going to call the first one MPLS and the second one and in-path 10 internet. And for the network, I'm going to select MPLS, but in-path 00 and internet for in-path 10. Just so it's all consistent with our design. Okay, so that's all set. Next, I'm going to add a site to define our data center. So I'm going to call it data center. And the subnet there, we know it's for this subnet for that this server's in. We know it was 10.1.31.0/24, and we obtained this when we were on that remote host. We could see it here, N31 Ashburn 1, 10.1.31/24, 10.1.31/24, and we know the steelhead's in-paths at this site are, so we connect to the server-side steelhead, view the in-paths, and we know the in-paths are 10.1.130.31, and 10.1.230.31. save that. The local site, we need to add the gateway IPs as well. So we need to go back to the branch steelhead and put in the gateways for each impasse. So for MPLS, which is impasse 00, this gateway is 10.1.120.1. So we've gone to impasse 00 gateway. Next impasse is impasse 10, and its gateway is 10.1.220.1. I'm going to copy that and put that into the internet uplink, which is impasse 10. And we're going to save it. Okay, so we defined the remote site as having this subnet and these impasse at that site. And we defined our local site as having this subnet, these impasse located at the site, two uplinks, one called MPLS, which is connected to impasse 00 with a gateway of 10.1.120.1, another uplink called internet, which is connected to impasse 10 and has a gateway of 10.1.220.1. Next, we're going to enable path selection. So we need to go networking, path selection, and we enable save path selection. Okay, so at the moment we've got one default rule, and our uplink status, if we refresh, we should see our two uplinks, MPLS and internet, both showing healthy, but the peer availability is showing as unknown. And it's not checking yet as we've sent no data. Okay. So let's create a rule. So that let's do the current default rule, which is any application, any site, relay. So just don't do any intelligent path selection. So we'll change this to say by default, always use MPLS first and use internet second. And we'll save it. And this is for all traffic, all applications, all sites. Okay, so if we disconnect our, just save the config, go to reports, current connection. If we disconnect our mapping to the drive and rebuild it, we should see which path it takes. And it should take the MPLS path as per our rule. So we disconnected the map drive. Let's send a reset as well to close the connection. And then update the report. And now we don't have any connections on 445. Let's map the drive again to the remote server. Enter the credentials. And then check the current connections report. And we can see the connections back. Open up the connection details, and we can see it's using the MPLS link. Okay, so that's working as expected. Let's disconnect, let's kill that connection again. Reset the connection on the steelhead. And we'll change the rules so it takes the internet path first, if both paths are up. So the connection's gone. Let's go in and change our path selection rule. And we'll change it. So it always takes internet first if they're both up, and then MPLS second. Save it. Rule updated, and we'll create a new connection. So we'll map our drive again. Then we'll go to reports. I'm going to go to reports here. I'm going to keep this tab on path selection. So we can see the uplink status, and I use this tab for the reports. Reports, current connections. We've got our connection back on my drive, and we can see it's using internet. Okay, so that's still working. Okay. So next, we've got internet first and MPLS second. Okay, so let's take down this link, this internet link, and that connection should fall back to the MPLS circuit. So we need to go to our PuTTY connection manager. We go to our controls. We can find out the name of the router at the client side. We have two. We have an N220 and an N230. It's the N220 router 1. Let's try connecting to that one. Same credentials again, my ELAB bang, my ELAB bang. Let's check the IP addresses on the interfaces, and we can see gigabit Ethernet 2 as IP 10.1.220.1. which we can see 10.1.220.1 is the gateway for the internet uplink. So we're going to take that gateway down. So at the moment, in current connections, the connection is going over the internet. And we can copy things. And it's going over that internet link. We refresh the report. We should see the kilobytes increasing. There we go. So connection traffic's going over there, and it's going over the internet link. And path selection shows both uplinks as healthy. So we're going to disable that internet link. by shutting down Gigabit Ethernet 2. So it's shut down now. Then if we refresh the path selection page, the internet uplink should show us down. Critical peers are all down because that gateway's down, can't go anywhere, can't get to the remote in-paths, can't get to its gateway. So now, traffic, it's matching this rule, should now go over the second action. Internet is down, so the traffic should go over MPLS. So we still got that connection, still active, going over the internet, but we now know the internet's down. So can we transfer data? Let's delete this. Well, we can delete that. Even deleting an item requires communication. So what's it communicating over? We can copy data there. Yep. We refresh. Do we see the data on this same connection increase? We do. Okay. So what link is it using now? And it's using the MPLS. So halfway through the same connection, it switched from using the internet uplink to using the MPLS uplink because the internet uplink's down. Okay, so let's bring up the internet uplink. By enabling Gigabit Ethernet 2. And we see we've administratively brought it up. And it's now showing connected as well. If we go back to our path selection page and our branch steelhead, refresh the page. We can now see the internet uplink is showing as healthy. Can we perform operations on that share? As you can see, the share is never disconnected. So it's not disconnected. The Windows doesn't know there's been any problems. Let's try deleting this data. Delete operation looks like it's going to be successful. Copy data. Copy operation is in progress. Let's check the current connections. So we had 2549 before. Let's update it. Yeah, it's gone up. Let's see which path it's taking at the moment. Now both uplinks are healthy. And we can see the one at the top is now the internet, and this is the one it's currently using. So it's gone back to using the internet uplink via 10.1.220.1. And both uplinks are healthy. You can create more precise rules. We could have captured that traffic on an application, and the application we're using is CIFS. So we could have created a rule for CIFS to the data center. use, so by default, we've got MPLS first. Sorry, by default, we've got, what have we got first? By default, at the moment, we've got Internet first, then MPLS. So we can create a rule just for sys, going to the data center, to use MPLS first, then the Internet, so the opposite. So now we've got a rule for sys application, go into the data center, use MPLS first, then the Internet. All other traffic, use the Internet first, then MPLS. Okay, so let's test that. So let's disconnect our share. Check our current connections, reset the old connection, update, and we don't have any sys SMB connections at the moment. We'll remap the drive, refresh the current connections, and we can see there's a sys SMB connection. So based on our rules, we would expect it to use, because it's sys, we would expect it to be going over the MPLS connection, not the Internet connection. Let's check current connections. And it is indeed going over the MPLS connection. It looks like it did actually send some over the Internet, and that would have been while it was identifying the traffic type. And because we're using application to match, until it identified that connection as sys, it would have gone into the any rule and used the Internet, which we can see here. Then when it identified the traffic as sys, it was matched to the sys rule and switched over to the MPLS link. Thank you for your time today. I hope you found this info video helpful. Thank you very much.